So far we've essentially been calculating velocity from position, acceleration from velocity and so on, which has required us to differentiate. Now we're going to go the other way and anti-differentiate. And there are a few little clues in this question that will help us out. First of all, the question says that a particle starts from rest. Now what that means is when time equals 0, the velocity equals 0 because it's not moving. And secondly, it says that the particle starts 5 meters to the left of the origin. So that means when time equals 0, my position will be -5 meters. So negative because it's to the left. And it moves in a straight line with an acceleration as given. So we know that at the start, A equals 3t minus 2. So now let's try and work out our velocity from this. Now we know that the derivative of velocity, dv dt, is acceleration. So we're now going to go the other way and say that the velocity is the integral of acceleration with respect to time, which is the integral of 3t minus 2 with respect to time. And that becomes 3t squared over 2 minus 2t. And then we've got our constant. And that's important because that's going to help us with our velocity and our position. So here we know when t equals 0, v equals 0. So therefore 0 equals 3t squared over 2 minus 2t plus c. But all of these t's equal 0. So this becomes 0 and this becomes 0. And therefore my constant c equals 0. So that means the equation for velocity will be this phrase here, or this equation here, with a 0. So I'll write that down here. So velocity with respect to time equals 3 over 2t squared minus 2t plus 0. So I'll leave that out. Now what I need to do is find the position with respect to time, and I'm going to anti-differentiate this. So if v equals 3 over 2t squared minus 2t, then x will equal the integral of that, 3 over 2t squared minus 2t, all with respect to t, which equals 3 over 6 t cubed minus 2t squared over 2, and then we have to add some other constant, and I'm going to call that d. Now let's tidy this up. We're going to get a half t cubed minus t squared plus d. We know that when t equals 0, x is -5. So we can write that down, and therefore -5 equals a half times 0 cubed minus 0 squared plus d, and therefore d is -5, which means this equation here with a -5 will be what my position is. So my position with respect to time will be a half t cubed minus t squared minus 5. And now I've calculated the equation for the velocity with respect to time and the equation for the position with respect to time by using acceleration and the initial conditions. If you found this video helpful, please subscribe or like. Thanks.